Hello everyone, myself G.K.Ukesh Karthikeyan. Today in this video we are going to solve the gate problems given to us. So let's go to the video. At first, this first question is: in the following circuit, the switch is closed at t is equal to 0 and the rate of change of current di by dt of 0 plus is given by. The given by is thing we have to find this problem. Here they have given a circuit like a current source Is and a shunt resistor Rs, a resistor R and an inductor L. Other than this, a circuit switch is given as S. So let's go into the question answer deeper. Like when the switch is closed at t is equal to 0, that is when the switch is closed at t is equal to 0, this inductor will be acting as an open circuit. Since the inductor does not have a capacity to change its value, that is change its current instantaneously, so this inductor will be acting as an open circuit. Okay, then let's denote the inductor current at first. The switch is at 0, that is I of 0 plus, and the current Is will pass through the shunt resistor Rs. That is, when first the current source is turned on, the current will pass through this direction and then it will be going to this direction. So the current will be passing to the Rs, that is shunt resistance. And then the voltage across the inductor is that this inductor is given by the Ohm's law, that is Kirchhoff voltage law, KVL, that we already know in the letter before semesters, by using the resistor value and the inductor value. So the formula will be VR plus VL is equal to Is into Rs. This will be the formula to find that voltage across the inductor. So VL is equal to Is into Rs. Since at I of 0 plus, that is when the switch is put to the closed circuit, when the time at 0, the inductor will be acting as an open circuit, right? Therefore I of 0 plus is equal to 0, that is VR will be a value of 0. Therefore this VL will be eliminated. Therefore VL is equal to Is into Rs. So VL is equal to IL into Rs. Therefore by the voltage across the inductor also is given by VL is equal to L into di by dt. Therefore, substituting this VL into L of di by dt, the equation will be changed as L of di by dt of 0 plus is equal to Is into Rs. The equation will be changed like this. When this L, inductor value is coming to the right side, it will be going for the denominator side. Therefore, di by dt of 0 plus is equal to Is by Rs into L. This will be a final answer. So let's go into the question again, and they have given 4 options there. A options of 0, B options of Rs Ls by L, and the third option is of R plus Rs of Is by L, and the D options of infinity. So as we have find the answer as di by dt of 0 plus is equal to Is Rs by L. Therefore the answer will be option B, Rs Ls by L. This will be the final answer of this question. Therefore the rate of change of current di by dt is given by Rs into Ls by L. That will be the final answer. Okay, let's go to the second question. The second question they have given us in the figure: A1, A2 and A3 are ideal emitters if A2 and A3 reach 3 ampere and 4 ampere. That is, if A2 ammeter reads 3 ampere and A3 ammeter reads 4 ampere, then what will be the A1, that is ammeter 1 reading will be? That's the question given here. So coming to circuits, ammeter is connected with two another ammeters, that is A2 and A3 in a parallel manner, and then that inductor and the resistance also connected parallel to the first ammeter, that is A1, and voltage source is also given there. So let's go into the answer, right? Therefore this inductor and resistor are in parallel, right? That is, the inductor and resistor are in parallel connection. Therefore the total current to be find out will be the formula of I total is equal to I A2 square, that is ammeter 2 reading square plus ammeter 3 reading square, the whole square root. Therefore substituting the values, that is they have given that A2 ammeter reading will be 3 ampere and A3 ammeter reading, that is third ammeter reading will be 4 ampere, right? Therefore, substituting the value at 3 ampere square plus 4 ampere square, that will be result in 9 plus 16 of whole root. Therefore, square root of 25 will be 5 ampere. Therefore, the total current flowing through this circuit, like this, that is this whole parallel circuit will be a 5 ampere. Since we have found that this two ammeters are in parallel, therefore by the total current formula that is flowing through this loop is 5 ampere, right? Therefore, this 5 ampere will be the current flowing through the ampere 1, that is ammeter 1 reading also, because this ammeter 2 and ammeter 3 are connected parallelly to the ammeter 1. Therefore, what the reading flowing to the A2 and A3 parallelly will be the result of the reading of ammeter 1. Therefore, since we have find that here the ammeter reading, that is the I total is 5 ampere, right? Therefore, that will be the answer of the ammeter 1. Therefore, we look about the options, like first options of A options of 1 ampere, B option of 5 ampere, C options of 7 ampere, and D options of none of these. Since we have find 5 ampere, therefore the answer will be B, option B, 5 ampere. This will be the answer of this question. That's the final option, final answer of this question. Let's go to the third question. The third question, they have given a circuit which consists of an voltage source with the 10 volt and 1 microfarad, and the circuit, that is the circuit switch, and a current loop of I and an 1 kilo ohm resistor. They have said that the current in the circuit when the switch is closed at t is equal to 0. You have to find that what will be the current in the circuit when the switch is at time t is equal to 0. Let's go into the answer. Like for the initial current calculation, using Ohm's law, we can find that the current through, like this current loop answer, that is the current loop value will be found out by the Ohm's law, that is given by I0, that is like I0 is equal to V by R, that is this value of the voltage source 10 volt and the resistor given as 1 kilo ohm. That will be the used in the formula. So 10 volt by 1 kilo ohm, that is 10 by 1000 is equal to 0.1. 0.1 will be 0.1 ampere will be the loop current. Therefore, 0.1 ampere is also can be referred as 10 milliampere. And then actually in an RC circuit, the current, that is the current we have found out here, right? I of 0, that is actually the I of 0 will be decaying, like this RC circuits are like in an RC circuit, the current I of t decays exponentially over time. That is that the current I of 0 we have found here, right? That will be decaying over the time exponentially. Therefore, for finding that thing, I of t, the formula is the I for that thing we have to find this I of t is equal to I of 0 of e power minus t by RC. Therefore, this will be the formula. Therefore, coming to this formula, we have to find the RC value, right? For that finding of RC value, RC is equal to, like R is of value 1 kilo ohm of 1000 ohms and 1 microfarad is of the capacitor value. Therefore, 1000 into 1 into 10 power minus 6. Therefore, that will be of answer 10 power minus 3. Since these values are in the unit terms, therefore it will be 10 power 3 seconds. Therefore, it will be taking 10 power minus 3 seconds. That's the tau value, that is RC, tau value. Therefore, the current at time t is I of t is equal to this value. What this value? This value is of I of 0 value, right? I of 0 value is 10 milliampere, that is 0.1 ampere. That will be substituted here. Therefore, 0.1 ampere into the value which we found here, right? That is of value of tau value, that is 1, that is RC value. Therefore, that will be substituted here another time. Therefore, which will be resulting in e power minus of t by 10 power minus 3 seconds. In this substituting, that is multiplying these terms, we will be getting the answer as 0.01 e power 0.01 into e power minus of power 1 by 0.001. When this 0.001 gets into the numerator, it will be resulting in the value of minus 1000, that is 1000. Therefore, 0.01 into e power minus 1000 t. When the current flowing the circuit at t, the switch at the time 0, the switch will be closed as and the value will be 0.01 into e power minus 1000 t. That is, as given in the question, there are four options. A value, sorry, A option, B option, C option. In this, the current in the circuit, that is that loop current circuit, when the switch closed at t is equal to 0 is option B, 0.01 into e power minus 1000 t. This is the thing we have found here in the answer. So this is the final answer for this question. That's all for this question. And then we are moving to the fourth question. Like given us an input voltage V of t is equal to 10 into root power 2 cos of t plus 10 degree plus 10 into root 5 of cos 2t into 10 degree. Voltage is up. That is, this voltage is applied to the series combination of resistance R is equal to 1 ohm and the inductance of 1 Henry. These are simple terms given here. The resulting steady state current I of t in ampere is that is, we have to find the steady state current in the resulting steady state. That is the thing we are going to find out. Therefore, for going to the answer, they have given us input voltages. That question we have read that V of t is equal to 10 root 2 cos of t plus 10 degree and 10 to 5 root 5 of cos 2t into 10 degree. Therefore, like at first, in the RC series circuit, the current response to a sinusoidal input can be found out using impedance and phasor analysis. So, for the phasor representation, we are going to the first component like V1 of t. Like this is the first voltage they have given, right? Here we have given the first voltage, right? That will be of in this we can see that frequency is 1 radians per second and phasor of V1 is equal to 10 root 2 10 degree. And then for the second component that is given here in the question, that is frequency will be 2 rads per second, since the value that is the coefficient will be the frequency. Therefore here 2 radians per second and the phasor will be 10 root 5 into 10 degree. That will be the second phasor component. And then for the impedance calculation, in an RC circuit, impedance is given by Z is equal to R plus J omega L. Since we have found out the omega value, and then we have the L value also. Therefore, Z is equal to resistor value is already they given that 1 ohm in the question. Therefore, Z1 is equal to 1 plus J, and the omega value is 1 radians per second. Therefore, 1 into the Henry, that is inductor value is 1. Therefore, 1 plus J into 1 into 1. Therefore, the answer for Z1 will be 1 plus J. And then for the Z2, that is second impedance, that is 1 plus J of 2 into 1. Since here the omega value is 2 radians per second. Therefore, 1 plus J into 2 into 1. Therefore, the value for Z2 will be 1 plus 2 into J. Since we have found the phasor representation and the impedance for the two components, let's go into the next. Next we have to find next we have to convert this impedance into the polar form, right? Therefore, Z1 will be the modulus side. Therefore, since modulus value will be eliminating these imaginary terms, making it as 1. Therefore, 1 square plus 1 square the whole root. Therefore, root 2. Then that theta will be like normally we find the value by tan theta. Therefore, when theta to be find out, it will be made as tan inverse. Therefore, theta 1 is equal to tan inverse of 1 by 1. Therefore, value will be 45 degree. Like Z1 of root 2 is equal to 45 degree. This is the first component impedance, like in the polar form. And for the second impedance, that we have find as 1 plus 2j, right? Therefore, when we are taking in the absolute value, 1 square plus 2 square the whole root will be the answer. Therefore, 1 square plus 2 square the whole root, that is 1 square is 1 and 2 square is 4. Therefore, 1 plus 4 is equal to 5. Therefore, root 5. Therefore, theta 2 is equal to tan inverse of 2 by 1. That is approximately the value will be 63.435 degree. Therefore, Z2, that is impedance 2 in the polar form, right? Polar form will be root 5 into theta value of 63.435 degree. Therefore, at last, in this, we are going to find the steady state current, right? Therefore, the steady state current in the phasor right? Phases are given by I is equal to V by Z. Therefore, for the first component, the current will be I1 is equal to V1 by Z1, right? Therefore, V1 is 10 root 2 into 10 degree, 10 root 2 into 10 degree divided by the impedance we have find here, right? 2 into root of 45 degree. Therefore, 2 root 2 of 45 degree. Therefore, the value by like substituting these values and finding this, the answer will be 10 into 45 minus 35, that is 35 minus 35, since 10 minus 45, right? Therefore minus 45. Therefore the I1 value will be 10 into minus 35 degree. Therefore the I1 of t, the steady state current is I1 of t is equal to 10 cos of t minus 35 degree. And then for the second current, that is for the second component, I2 is equal to V2 by Z2. V2 as in the question they have given as 10 root 5 into cos 2t into 10 degree. This is the second component voltage. Therefore that is written here. And the second impedance value that we have found, that we have currently found here, right? 5 degree of 5 root of 63 degree 0.435 degree, that is substituted here. By calculating by these values, we will be obtaining the value as 10 into the minus 53.435 degree. Therefore simplifying this term, I2 will be 10 cos 2t, since it is a frequency like omega value of 2. Therefore 10 cos 2t minus 53.435 degree. Therefore for the resulting current, that is we have, since the voltage is comprising of two components, right? Therefore the two components will be, the two currents will be summed here, that is summation here. Therefore I of total current I of t is equal to I of t plus I2 of I1 of t plus I2 of t. Since we have found out both the values here, right? That is I1 of t and I2 of t. Both the values we have found here. Therefore adding these two values will be the answer. Therefore 10 cos of t minus 35 degree plus 10 cos of 2t minus 53.435 degree. This will be the answer. Okay, thus we have find the answer. Let's go to the question and check it. Since they have given 4 options, that we can check it, a question like t plus 55 degree not, and b is of t again 55 degree not the answer, and then 35 degree 35 degree. But we have found that 2 plus 10 minus tan inverse of 2 degree. Sorry, 1 minute. Right, that's the thing we have found here. Therefore it's scrolling down. We have found that 10 cos like 53 minus 4.35 degree is tan inverse of 2, right? Therefore that is substituted here. Therefore looking upon the options, the option C, that is 10 cos t minus 35 degree plus 10 cos 2t plus 10 minus tan inverse of 2 will be the final answer. This is the final answer for this fourth question. That's all by my side. The four questions and their answers are currently discussed here. Therefore from my side, thank you.